Hey guys, welcome to DevOps School. Kubernetes is one of the most popular technology in cloud computing as of today. Learning Kubernetes is essential for any DevOps professional, and one of the most in-demand certification is Kubernetes Administration. In this session and in this series, we are going to learn various aspects of Kubernetes Administration, which will help you to prepare for the Certified Kubernetes Administration exam or CKA exam. This series is divided into 20 parts, therefore subscribe to our channel and follow the playlist for complete understanding.
Okay guys, so let's get started. So today I am going to discuss about nodes. Nodes is also being known as minions, and then also we call it the Kubernetes worker. Okay, so node is having three important components. Okay, three important components. So before discussing about these three important components, let's discuss about what is the meaning of nodes and what is the behavior of nodes. Now, I believe, have you seen the movie called Minions? It's an animated movie, and Minions is a nice storyline. So, anyone have watched that movie?
No.
You must watch. Probably this weekend you can try it out. So, in the Minions movie, there's just one storyline. Minions gets up, okay, in the morning. All the minions is a kind of species which gets up in the morning and they get sad. Why they get sad? Because they get sad because they don't have any master, they don't have any manager, they don't have any coach. So minions feels like their life is meaningless, not existence without master. So they need a master. So minions needs master. Without that, they are sad. So they travel around the globe in order to find out the master, and minions find out the master and request master, please manage me. When master says okay, I will manage you, then minions again keep bugging masters, saying that give me the work, I will do that for you, I'm free, I'm alive, I'm healthy, I can do that for you, I can do that anything for you. So whatever the master says, minion will do that. Okay, something similar story what we have here in nodes also. Node existence is meaningless as part of the cluster if he's not able to do certain jobs. So nodes get sad as part of the cluster. So nodes gets up, look for the master, register a node with a master, and keep bugging master, saying that give me the job. I have this much of CPU, I have this much of RAM, I'm still alive, I'm still healthy, give me the work, like that. So that's the storyline for the minions, also known as nodes and Kubernetes. With that introduction, let's get started. So node, basically, we have a three important component. First important component is a kubelet. Now the question is, what is a kubelet? A kubelet is a main Kubernetes agent which is running in each node. Let me tell you, running in each node. If kubelet is not running, that means that node is not a part of Kubernetes cluster. I said minions gets up. Kubernetes agent kubelet gets up. Kubelet runs. I said minions gets up and look for the master. Again, kubelets run and look for the master. Minions gets up, look for the master and search for it in the whole world. Kubelet gets up, kubelet runs, look for the master, and their kubelet whole world is a node itself. Now all the computers this search, but basically there's one file which is having the address of master. So kubelet look for the file which is called kubelet.conf, lying at somewhere in etc directory, and the address of master is found in that kubelet.conf file. So kubelet runs, look for the conf file, get a master address, request a master saying that master, please manage me. Once the master approves, okay, you are my kubelet, you are my minion, you are my node, you are my worker. Then kubelet again keep bugging the master saying that give me the job, give me the job, give me the job. So this is something which happens with the kubelet, also known as a minion. So yes, the minion Kubernetes, the main Kubernetes agent the
Rajesh,
cluster
hey
watches
Rajesh,
API server, keep bugging API server. Yeah, please.
hey Rajesh,
Yeah,
Rajesh. Not sure for me, but your voice is
yeah, tell me.
breaking.
Or is it?
Yeah.
Same here.
Everyone?
Same here. Yeah.
Just a second.
This conference will now be recorded.
Okay, yes. So I was talking about the kubelet. So Kubernetes, of course, this is the main Kubernetes registered a node with the cluster, watches API server. And remember, kubelet instantiates a pod. Hardcode this line. Kubelet instantiates pod. Now the question is, what is a pod? Discuss. We'll come back to this. But kubelet keep bugging API server saying that, okay, give me the job, I'm alive, I'm healthy. Now kubelet reports back to the master after the work, and kubelet runs on 10255 on each node. So kubelet is an agent on each node, and if it is not running, that is not a part, that node is not a part of your cluster. If it is running, it read one configuration file, and then from there it connect to the master. And initially the first exchange happen, approval and all, but after that, once it's connected, it's keep watching the API server. Now second important element of node is worker is container engine, and this is something which I assume you all know. I think for some of you we had a session on Docker as well. So here the beauty of the Kubernetes is, here the container engine, it is which is by default Docker, but here it can be Rocket, Trio, Container D, and many other engines also. That is a beauty about that. So yeah, what container engines will do, what Docker can do, just pulling the images, starting, stopping the container, and all the things which you might have already experienced. As I have already stated, this is a prerequisite for this training. And the third element which you can see is Kube proxy. So before understanding what is a Kube proxy, let's understand what exactly networking environment we need in Kubernetes nodes and Kubernetes cluster. Okay, so here if you read it very carefully, we in Kubernetes we have a master, we have a node. Inside the node, if you remember, we have a pod. If you forgot, let me remind you that flow once again. So that way, see here, we have a master, and a master has a 4 component which we discuss. Now we are discussing about the node, and node we have a 3 component. But you see here, node has a pod, and pod has a containers. So you have a multiple node. Each node has a multiple pod, and each pod you may have a 1 or multiple containers. So now I'm talking about the pod networking. So the requirement for Kubernetes in terms of networking, all pod can communicate with each other on all nodes. Why? Reasons are very simple. Because at any given point of the time, remember the microservices discussion. If you have remember, the pods have a container has application, and applications you need to access, and these application and these pods can run anywhere, because Kubernetes view the entire data center as a one computer, so it can run anywhere. So now some pod of one service, which is let's say HTTPS, is running in node 1, same pod is running in the node 2. So here the requirement is to load balance to work. All pods should communicate. All pods can communicate with each other on all the nodes. If all the pods cannot communicate with each other on all the nodes, so how the load balancer will work, how this will interact with each other. So that's one of the basic Kubernetes networking requirements which we have. Second requirement is we have all nodes and communicate with all pods. See here. The third requirement here is there should be no network address translation should happen. No NATing. So how come you can have it this requirement fulfilled? And these three requirement is been fulfilled by Kube proxy. So Kube proxy is the third element in a node worker convenience. And Kube proxy basically is a networking services. Okay, Kube proxy is a networking services. Now Kube proxy assign a IP address to the pod. Again, I'm repeating here in this case, in the Kubernetes case, Kube proxy assign IP address to the pod, whereas containers don't get any network assigned. Containers don't get any network namespace assigned. Pods get assigned the network namespaces by the Kube proxy. So all containers in a pod share a single IP address. So you may have a multiple container in a one pod. So pod gets IP address. If you want to access those containers from outside, you have to use the pod IP address. And because of this, the Kube proxy manages the pod IP address. It helps load balances across all the pods in a service. What is a service? What is a pod? I am going to come back. But you know that by now pod has a container and container has application which is managed by the Docker. So this is the three important component what we have in worker. Kubelet, which is the main Kubernetes agent, Docker engine, container engine, and Kube proxy, which is a networking services. Now, this is a little bit elaborated picture. If you see this picture here you have two nodes. Okay. Each node you have a Kube proxy. Okay. Now you see that each node you have a pod. Okay. If you see the top node, you have a three pod. All these three pod is connected through one bridge. Okay. So that bridge is powered by Kube. That bridge is powered by Kube proxy. Now these pods have a containers. You see the containers. The icon is different here. In one pod you have a two containers. These two containers connect to each other through the local host. Now all these pods get load balanced through the service with the help of the Kube proxy. Now what is a pod? What is a service? I'm going to discuss on this. Okay, but this is the Kube proxy, which is the networking services which is made it available for the pod to pod networking related things. Okay, so finally, Kubelet is a main working agent, Kubernetes agent. Container engine is a Docker. Kube proxy is a Kubernetes network. So overall, how the nodes communicate with the API servers? Do you see here? The master, you have a four component: cluster, source, scheduler, controller, manager, and API server. Here, Kubelet keep watching the API server for the new job. I said minions keep bugging the API server for the new job, and Kube proxy is also talking to API server for allocation of the CIDR and stuff like that. So we have a networking topic pending in detail. So I'm going to discuss networking in that session also. Okay, and then container engine. So overall, this is the overall functionality of this three component. Kubelet monitors API server for changes, responsible for pod lifecycle, reports node and pod states, and also pod liveness and props. So what is a pod liveness and props? It's pending topic. I will talk about it. Here nodes, which is has a Kube proxy, which is a network proxy IP tables, implement services, routing traffic to the pods, load balancing. Now third one is a container runtime, which download the images that run the containers. It has interfaces, container runtime interfaces, Docker, and many other. Now you may find other component apart from the one which we have discussed in the master. In the master, we had a 4 component. Apart from that, in the master, you may find this component. You may find DNS component, which is a discovery services. You may find ingress. You may find dashboard and stuff like that. So you may find additional add-ons, but it's not a core part of it. So depends on the need, you may get it. So now with that node introduction, I'm going to discuss about the declarative model and the desired state. Okay, so what is a declarative model versus desired state? So nowadays, if you want to do some certain programming, okay, so nowadays you do not write programs, you declare it. Now you have a desire, and you declare it. The question is how you have a desire, and in a Kubernetes, what desire you may have it. Of course, a desire you may be having is I want to run a pod, because pod ultimately has a container. Container has a application.
One question, Rajesh.
Yeah.
Sorry. So my question is more on so the idea is when I see the desired state, it reminds me like Ansible, like we will put in Ansible like the same thing, like what is the desired state we need. So when you do a coding in, my main question here is when we do a coding in YML, right? Do we have a particular format how these products know like that? Like pod, when we write a pod, like you have API, kind, and service and spec. For Ansible, you will have some YML file where you have role and tasks and all. So is that product specific YML you will do?
See, YAML is a global standard for expressing the desire. Okay, declare the desire. Now, YAML has a certain formats, and these formats are like a list and keys and value and stuff like that. So each tool, read these list, dictionaries, keys and values in a certain formats. Okay, and the YAML standard is global, but how each tools will read from this list and dictionaries is different. Now Ansible, when you talk about Ansible, we do declare that desire in YAML file, and this YAML file will declare in form of playbooks. Again, if you look at that the YAML file of playbook and YAML file of any other YAML, the format will remain same. It will be in a form of list and dictionaries. List, which has a multiple elements, dictionaries has a multiple key and values stuff. So that way each tool read that YAML file and manipulate what exactly you are trying to get it. Okay, so it depends on that format. So there's no certain answer for it, but yes, again, if you want to go through the YAML rather than getting into the YAML, Ansible YAML or Kubernetes YAML, both are same. Just you need to understand the YAML first. So go through that, and then you understand how that's being called.
Okay, that makes sense actually. I got. I was thinking in the same means I did not understand when we were talking, so now I am clear. Thank you.
So basically, yes. So here declarative model. So what you have desire, you declare. You don't write it the program nowadays. So you desire what? In desire phase, you want desire pod. I want this pod. I want this many pod. I want the pod of this image. All this thing you desire. And where do you declare? You declare in a YAML or JSON format. The moment you desire and declare in YAML format, you give it this desire file, declarative file to API server, and you know that as per the discussion, everything would be done by Kubernetes. Okay, you don't have to do everything, will be done by them. So now, yes, You declare in YAML or JSON of what? You declare of 3 pods of Nginx, send to API server. Now you know that from the API servers how the things will take further. It will store in the KV store, controller keep reporting about the status of the cluster, scheduler will do the changes based on the request from the API server. Node also you know that how it works, and then ultimately you got the 3 pod created and each pod got a containers of Nginx. That is what you wanted. Desire and actual is matching, everyone is happy. But suddenly what has happened? One of the nodes got offline. So when one of the nodes got offline, that had one pod and pod had one container. So the desire and actual is not matching. And desire and actual is not matching, there's a problem. So what to do? So when the desire is and actual is not matching, you don't have to do that. Remember, Kubernetes will take care of it. Kubernetes immediately controller will detect, okay, there were only 2 pods, whereas API server will report saying that there were 3 pods which was desired. So I have to create one more, and immediately Kubernetes will ask, API server will ask scheduler to go assign a work, create one pod, and the third pod will be created with the help of the kubelet, instantiated with the help of the kubelet, and Docker will be filling the container inside that particular kubelet pod, and then everyone will be happy, and desire and actual will be matched. So this is the game about the declarative model and desire model. So what are the things you can desire? What are the objects you can desire? You can desire for pods. You can desire for controllers. You can desire for services. You can desire for storage. Now, the real learning is in Kubernetes to know how to perform desire. That is the main question, how to perform desire. You need to learn all this Kubernetes API object, we call it API resources as well, to perform a desire, because that is your work, because you know that Kubernetes will be doing rest of the work. So you should know how to perform desire, what to desire and how to perform. This is the stuff which you need to know. With that introduction, I'm going to talk about what is pod. What is pod? So, what is pod? Now, try to understand this perspective here. You know hypervisor, which we are consuming from last 10-15 years. What is the atomic unit of scheduling in a hypervisor? Atomic unit of scheduling in a hypervisor is virtual machine. So basically, if you say create a work in a hypervisor, they will create a virtual machines, right? Now, if you go for the Docker, now you've been using the Docker. What is the atomic unit of scheduling in Docker? Containers. So Docker, when you want to run something, you get a container. On similar line, Kubernetes has no understanding about virtual machine and container, because container is managed by the Docker, VM is managed by hypervisor. So who's managing the pod? The pod is the atomic unit of Kubernetes. That means Kubernetes understand pod. When you want to create some compute unit in Kubernetes, basically Kubernetes can create a pod. Now the question is, okay, so atomic unit of scheduling in Kubernetes is pod, but what it contains? So see here, in the virtual machine, you have operating system which runs. In the container, you have images which runs. So in a pod, you have containers which it runs. The content of the pod is container powered by Docker. Now, VM is running because of the operating system is running. Container is running because of the PID1 and container services are running. Pod is running and containers are running. These all are interrelated. So ultimately, pod is atomic unit of scheduling in Kubernetes. So you may have a pod multiple pod. You may have a pod with multiple containers. Okay, that is there. Here, pods get a network namespaces. Here, pod gets mount namespaces. That means if you want to attach some volume to the container, you have to attach to the pod, not containers. I told you pods get IP address from the Kube proxy. So pod get net namespaces. Okay, so these are the things happens with the pod. All the pod which get assigned with network namespaces, mount and all stuff like that IPC. Inside the container can refer that same pod resources. If you look at this here, this is called tight coupling. Sometimes what happens? Developer will say, no, I want to run application and other application, maybe database, in the same machine. That means in a same physical machine or same virtual machine or same container or same pod. So if that is the requirement, if you have it. In terms of pod, you can run multiple containers here. Two containers in a pod, both share each other through the local host. Okay, this is called tight coupling. This is called loose coupling. One pod, one container. Each containers talk to each other through the network of the pod, not local host. This is called loose coupling. Now, pods can be scaled. If you look at this, one side it says it's the right one, another side says it's wrong one. The question is why it is wrong one, and the question is why it is right one. If you look at this, here one pod has a 1 nginx container, but another pod you have a 5 nginx container. So why it is wrong? Remember, pods get network namespaces. That means pod get IP address. And you also know and understand load balancer to work. They need different IP address but same port. So here only one nginx container can be exposed at certain port, let's say 80. That will be available for the load balancer. Rest of the pod, rest of the container of nginx in the pod cannot run on the same IP address because same port. Why? Because it's one network, and because of that reason, which 4 nginx container of this particular port, which is on right hand side, will not be serving to a load balancer. Is just a waste of CPU and RAM resources. So this is wrong. So basically in one pod you should not run a container with a similar from the similar images. It not make any sense. But you can sometimes tight coupling can happen. So two different containers from two different images you can run if you have a requirement to run in the local host.
Rajesh,
Yes.
can you please repeat this once, this image?
Yeah. So that's what I was saying. So here pod get a network. Load balancer to work, they will only need one IP address for each pod. Let's say 80. Now remaining container of that particular pod of nginx will get wasted because they cannot run on 80 again, because pod get one network namespaces. So you can run on only one container at 80 port, not all the container at 80 port. So here load balancer will only balance one of the container of the pod, not all the container, because all the containers got wasted because of it. So that means you are running the multiple containers in a pod. That means just you are wasting the CPU and RAM, nothing else.
Okay.
So yes, pod may have a multiple containers. They talk to each other through the local host. I told you pods get a network IPC mounts. All the containers share the same network, same IPC, same mounts. Pods can be scaled. One pod or another pod, it can be scaled. So from one pod to another pod, when you create from the ready to it's become a pending state, another pod. Okay. So these are the life cycle, pod life cycle which you have.
Rajesh, are you
Yes.
going to talk about the network IPC amount?
Yes, networking sessions we have in detail, in depth. So I don't want to confuse you all topics at a time. But yes, remember for time being, you need to hard code something. Here, each pod get a net namespaces. Each pod get their own IPC. Each pod get their mounts, and whatever it get attached to the pod, all containers can access it in a local host environment. Now, in detail, how IPC work, how the mount works, which the mount is like a volume, and how network works, I'm going to dedicate in the volume and networking session.
Okay, thank you.
So pod life cycle. So here, these are the life cycle of the pod. So pod is pending state when you get assigned. Remember, if you remember the story, scheduler schedule a pod to the node. So that time when it gets scheduled, that time it is in pending state. Then Kubelet instantiate a pod. That time also it is in pending state. But the moment Docker run a container inside a pod, and if the container is running, pod is running. Understand that? If the container inside a pod is running, all containers, not only one, all containers, one or multiple containers are running, pod is running. If container has run and done the work and container got exit, again read my lines. If the container has run successfully and done their work, and then container after the work got exit, then pod gets in a succeeded state. If the container run but failed to do their work, then pods get into the state of failed. If you remember Docker, let me remind you, if you remember Docker, how the containers get succeeded and how the containers get failed. If you want to understand, let me tell you the commands. If you recall this, when you run Docker, run Ubuntu and ls. ls is a write command. Let me tell you, ls is a write command in Ubuntu. So it will get succeeded, but after the work is completed, containers will get exit. It will display the root file system. But again, Docker run Ubuntu XYZ. XYZ is not an executable inside a container. So again, container will get created, but it will get failed. Okay, container will create, run, but failed. So in that case, if the container get failed, pod get failed, container runs and exit, pod get succeeded. So that is a life cycle of pod. So ultimately, let's recap the things. Yes, pods get their C groups, pods get namespaces, pod get networks. Each pod you have a multiple container. Each container talk to each other through the local host, whereas if you want to talk from the outside, you have to use the IP address of pod. If you want to access each container, you can access this each container of the pod using the IP address of the pod plus their port. And that is the story of pod. You see that here, one pod, one container. Each of these pods communicate with each other through the pod networking. Remember, the pod network is powered by Kube Proxy, which is running in each node. And in detail, I'm going to discuss about the Kubernetes networking in the upcoming session. Here you see both the pods, both the containers within a pod communicate with each other through the local host, but from the outside through the IP address and port number. So ultimately, pod is nothing but one or more containers. Pod is your application or service. It is the most basic unit of work in Kubernetes. It's a unit of scheduling. It is inferior, so that means if the pod is gone, data is also gone, and it is automaticity. So this is the all about the story of pod. Again, to continue with it, some of the other points. Kubernetes job keeping your pods running. So whose job to keep your pods running? Kubernetes. Okay. Kubernetes jobs to keeping your desired state, not you. Kubernetes will make sure that state, health, and liveness flow is continue. So yes, where you deploy a pods, so you say in YAML file you declare in a kind format. You say kind is equal to pod. Like that, declare the YAML file. Desire declare in YAML file is say kind is equal to pod and send to API server. So now the question is, what else can be desired? What else can be desired? So I'll just pause this recording for 1 minute.
This conference will now be recorded.
Thank you.
Hey guys. So I'm back. So yes.
Quick question, Rajesh. What's NetNS?
Okay. Here, see here.
Yeah.
Now, this is the inputs I'm giving it to you. You're going to read out more about this in Docker and Kubernetes session. So basically what happens in the Docker creates container. When it create a container, if you remember, I think some of you have gone through that the training of Docker also. So here container is nothing but a user space, user namespace, user name space. Okay. Now each user namespace, for example, what is a user namespace? In simple word, see, you have account in any operating system, you log in. That session is called user namespace, which is powered by user namespace. Okay. Now each user namespace in the container world get one network, correct? Okay, sorry, one network, and here one process map, map we call it, and one what do you say? I forgot. One mount, MNT. Okay, so here the question is, what is netness? So here netness is a network name spaces. In a Docker world, the container get net namespaces, but in the Kubernetes world, pods get all this. Pod get all this. Okay, here network, map, and MNT, who gets pod gate, and inside a pod you run container user space. So container is nothing but a user space. So this is the architectural differences which has happened. So now the question is, what is a NetNS? It is a network namespace which get assigned to pods in case of Kubernetes, and in terms of container with Docker alone, it gets assigned to the container. In Kubernetes, it never get assigned to the container. Is it clear?
Yes, it makes sense. Thank you.
So you can also study in detail Now the question is, what is a PMAP? What is MNT? What is network namespace in kernel? So you will build more understanding about that. Okay, guys. So yes. So now the question is, what to declare, what to desire in a declare YAML, declare in YAML file. So typically, when you desire for pod, but you don't desire for one pod. You desire for one pod, you get one pod, but you desire for more pod. I told you pods can be scaled out. So when you desire for the more pod, there is an API object available, and that object we call it replication controller. Again, please focus your eyes on the keyword. It states replication and it states controller. Now, if you remember my yesterday's discussion, I will talk about what is a controller. Controller will run in the loop to check something. Check something, it can be anything. Controller is a kind of script which runs in the loop, check the status and give the reports to whom? API server. And replication means one thing which you are going to replicate to multiple. So in a replication controller, you have a two feature. One, you can replicate a pod one to many. You can replicate a pod one to many. That means 1 to 10, 100, 200, 500, 5,000. That can be scaled. So that is called replication. But at the same time, a controller is there which will manage your actual and desired state. So if you have desire for, let's say, 10 pod, and due to some reason it got to 9 pod, immediately replication controller will immediately inform to the API server because it runs in the loop. They keep checking, okay, you desire 10, are we having 10 or 9 or 8, what exactly, or 11? Immediately controller will respond to the API server stating that desire and actual is mismatched, and same time API server, if you remember, will immediately ask a scheduler to schedule a pod. Again, immediately Kubelet will instantiate a pod, and Kubelet will ask Docker to fill the container inside it, and then container is running, pod is running, desire and actual is matching, and then everyone is happy. You are not doing anything. Kubernetes will do everything their own. Now, replication controller is a wonderful objects what we have. At same time, you need another more features. So we have a deployment. So now the question is, what is deployments? So deployment has a feature of controller, replication controller. So whatever all the feature we can see in the replication controller, you have in the deployments as well, but some plus extra features. For example, rollback, versioning, and many other features which was not there in the replication controller. So deployment is the current object. Using it, you deploy your application, deploy your pod. So these are the three objects you have to hardcore your mind: pod, one pod, application controller, multiple pod, deployment, also multiple pod plus XYZ plus feature.
Hey, quick
Now
question.
with that, yeah.
Rajesh, quick question. So this replication control is managed by controller from the master, right?
Yes, all the controllers. Remember that in the master there is one component called controller-manager.
Yeah.
So controller-manager has the list of controller, and these controllers runs in the loop to check different things and keep reporting back to the API server.
Okay, that's same to deployment as well, right?
Yeah, so same controllers you have in the deployments also, plus additional few extra features.
Thanks.
Okay, any other questions?
Yeah, Rajesh. So here in this image, it is saying pods are running inside controller, is it? Or something else it is meaning?
Pods are running inside a controller. I did not say that. I
Can I
said
understand the replication controller? So it is that replication controller uh, are at node.
okay. Try to understand here. Do you understand? Everyone understand pod?
Yeah,
Yeah.
pod.
Yeah.
That is or not.
That is a node. But what I said, remember, I said if you want one pod, so you declare one pod. I'm talking about the declaration. Forget about where it is. I'm saying you want one pod, so you want pod, so you get a one pod. But what about if I want 20 pod? So how to declare it? I'm talking about the declaration in YAML. How to declare? There's no looping because it's not a programming language. I said there's no programming language. You cannot loop, okay, I is equal to 1 and lesser than 21 and then create pod like that and run in a loop. You have to declare. It's a declarative language. There is no looping in the declarative language. How to loop? We have to declare another object. So now
Yeah.
replication controller again. Replication controller. Yeah. So please mute yourself. So replication controller is a object using your pods can be replicated to as many you want. Plus desire and actual will be always enact. It will be make sure that always you whatever you desire it has to be there. So let's say if you desire 10 pod, you will be having all the time 10 pod. That will be managed by your controller, replication controller. Am I making any sense now?
Yes, makes sense.
So ultimately replication controller is a way to desire you want 10 pod. So you put it in YAML. Basically replication controller is created just a controller. You get a 10 pod, okay? You get a 10 pod. Now through replication controller you get a pod. Using pod also you get a pod. Through the deployment also you get a pod. To all these objects you get a pod. But if you use the pod kind, you get a one pod. If you use the replication controller, you can get as many pod you want to replicate with. You can say replicas 5, 10, 2000, 2 billion, whatever it is. And in a deployment also, it has a feature of replication controller plus some more feature which is called versioning and rollback and stuff like that. So all these objects ultimately you get a pod, but some additional feature with. Make sense?
Okay, so this image is somewhere, it's a deployment, right?
Yeah, so here pod and application controller deployment. So typically we do the deployments. So when you are talking about the images, let me explain it to you. So here you have a pod. Pod has a container. Pods get a MNT, IPC, net namespaces and stuff like that. If you see dot, that means multiple pod will be part of the replication controller. If you see the replication controller is a part of the deployment. Like that I said, replication controller feature you have in a deployment plus extra feature. Got it?
Yeah, okay.
So basically in a programmatic way, if I want to tell you in a simplified way, it will be wrong to state, but it's like this. When you need a one pod, you call the pod, but when you need a replication controller, when you need a multiple pod, then you call the replication controller. That way what happens, replication controller call the pod that many times, so you get that many times pod created. Now when you need all addition, which is I have not discussed about the deployment, so you call the deployment. So deployments call the replication controller plus extra features which whatever you have in the deployments, which is like rollback and versioning. Make sense?
Yeah, just last question. So this replication controller is a one-time activity, right? Here to mention.
Yeah, you have to declare how many pod you want. It's a one time. Rest of the job will be taken care by Kubernetes, because you know there's a controller which keep talking and reporting back to the API server to maintain the actual and desired state. There was one more question from someone. What was that?
My question is, so replication controller monitors the number of replicas. So if we want 10 instances of pod, it monitors that, and if it's only 8, it tells API server, and API server instructs scheduler to make it 10. But say for example, if you want not just replica, but you want 10 pods on 3 different nodes, but you only have 8. That would not be a replication controller. It would be a different type of controller, isn't it? That would notify API server to say it's not actually 10, it's only 8. What type of controller would be doing that?
Okay, so it's like this. These are the objects to declare in YAML file. So when you say you want 10 pod, then you say, okay, kind is equal to replication controller. I want 10 pod. Then you want to reduce that same controller to 8. Then again you redeploy saying that I need this controller, this replication controller to be reduced to 8. So 2 ultimately will be cleaned it up. Again, next moment you say, okay, I want 10 to 20. So again you modify the YAML file, update that desire to your Kubernetes and say 20. So that way number of additional pods would get created. So that is how it works. Did that answer your question?
No, so this is you're talking about for example, you're talking about 10 instances of Nginx now. That's what you're saying. I'm talking about if you say for example 10 you have Nginx pod and you have a Q pod, you have other application pod.
Okay. So that's what I said. If you are creating a pod, see here, using a kind pod, okay, so that way you will get one pod. Now this pod belongs to the X image, okay. Here this pod belongs to Y image, this pod belongs to Z image. It can be any images. Now if this pod has gone, that means gone, there is no actual and desire will be packed. Why? Because here in order to pack the actual and desire, it required a controller, okay, which is missing in the pod kind alone. So that is the reason if you want to match the actual and desire, then you have to use the replication controller. Alone, if you are creating a 10 different pod, it will be running as long as the node has no issues, pod has no issues, container has no issues. But due to some reason, if it is gone, that means it will never come back automatically. It will not, Kubernetes will not create those automatically. Make sense?
Yes, thank you.
Yeah. Okay, guys. So now what we have covered very well with the master and node and pod. Okay. The next topic which we have is services, which is again large topic. So I'm going to pause this session. So let me just quickly pause this.
Thanks for watching. I hope you enjoyed and learned from this video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.